For learning target 3, we're thinking about using that age evidence to figure out what's going on with the seafloor. So for starters, we just want to remind ourselves the differentiation between the age of the continents, the land, and the age of the oceans, the water, or the rock under the water. It's an estimation that on average the continents are around 3 billion years old, whereas the oceans, if we look at our scale down here, range from 0 million years old to 280, depending on what you're looking at, up to 350 million years old. So when we compare those two, it's evident that the older rock on Earth can be found on the land, right? So the ocean is the newest area on the Earth. So when we look at our overall patterns of these rocks across the Earth, our young color is the red. On this map, our old color is the purple or the blue. And so we're noticing these similarities of the location of young rock to old rock across the ocean. Again, here we're just looking at the seafloor. We're noticing that this really young red rock can be found primarily along the middle areas of the ocean. So young rock is recognized in the middle of the ocean, where the oldest rocks can typically be found on the edges of the ocean, or we could say near the coasts, the coastline of the continent. So that would be these areas. And we definitely notice that the oceans do vary in age. For example, this ocean here, we're just going to call it Ocean 1, gets to approximately, 50 million years old, whereas this ocean maxes out at the 350-year-old, whereas this ocean gets to 70 million years old, right? So we are seeing a range in how old the ocean gets, but no matter where we look, Ocean 1, 2, or 3, we are seeing a pattern. And that pattern is that the rocks go young to old as you move across the ocean, right? I don't ever see a spot where I have, let's say, red stripes, for example, where it alternates young, old across the ocean. I'm seeing a consistent flow of young to old, maybe varying in how old the rocks get, but still young to old. And I also know that they are symmetrical or the same on either side of that young location. So wherever I see that band of young rock, no matter which way I go, I'm noticing that exact same pattern on either side. I'm seeing symmetry on either side of that young rock. So what does that mean? Well, it's cluing us in that we're not just looking at how the continents are moving, but we're looking at how the entire tectonic plate moves and how they interact at what we call plate boundaries. So what we're seeing here from this pattern is something known as seafloor spreading, where underneath the ocean crust, volcanic activity is creating movement because of the new rocks. So what happens is this volcanic activity creates new rock, which actually pushes those tectonic plates. So like on this image, we're seeing this volcanic material come up. We know that it's called magma when it's underneath the crust. Magma rises, pushes out at that mid-ocean ridge, that spot in the middle of the ocean where all the youngest rock is at. And as it cools, it pushes or puts a force on that tectonic plate, causing them to separate over time. So on those plates, that's where our continents are, South America and Africa. We're seeing those plates being pushed very slowly from this magma rising up, cooling, and moving apart. And so this is what we were missing with that idea of how the plates move. This new data about the age of rock on the seafloor clues us in to that motion piece and how those plates are driven apart. So when you're looking at learning target number 3, we're explaining the patterns that we're seeing, right? What we notice about location of old compared to location of young. So where do we see the youngest rocks? Where do we see the oldest rocks on the seafloor? And what is that pattern? What do we notice going across the oceans? What do we notice on either side? Again, you're giving a description here, not just bullet points. And then what do those patterns tell us about the movement of the seafloor? What's going on underneath the crust to actually move those tectonic plates? Okay, so the more detail you can have, the better. As always, when you're writing your summary, make sure you include all your keywords and highlight them up.